Hello, welcome back to the third part of the series, types of series and the series convergence test. What we're going to be doing in this video is the telescopic series. And the whole idea of the telescopic series is to find a series such that there's stuff inside, and at some point you're left with two numbers, the first term and something that's happening to n squared, n plus 1 something. And then at the end, you find the limit as n goes to infinity of the first term plus or minus, if it's a minus, whatever's happening to n, and that gives you the sum. So I'm going to give an example of a kind of series that is famously used. That telescopic series is probably the best option to use to find the divergence or the sum of the series. And one of them is not one of them, the series itself is if the series has something that looks like this, where at the bottom it looks like it's factorable, and on the outside or there's a fraction inside. And unfortunately, when you see a series like this and you want to use a telescopic series, we can't just use it right away. We have to do something called partial fraction decomposition, where we're trying to split these two into two different fractions. And we can't just split them since they're multiplied. So we have to find out a over n, which is one of them, and then plus b. And these are just constants that we're gonna have to find eventually. And then it's b over n minus 1. And partial fraction decomposition could be something that you could have learned in previous classes. I think I remember learning about it in 2b, where you try to find the coefficients, and you do that by you multiply this with this and this with this. So you have the numerator, which is here 1, is equal to a times n plus b times, a times, because it's n plus 1 over here, n minus 1 over here, plus b times n. And then you plug in things like, I'm going to plug in 1 because it cancels out and leaves us at 0. And you plug in 1. 1 doesn't change over here, so it's still 1. It's equal to a of 0 minus 1 plus b times 1, n is 1. Then it gives you 1 is equal to 0, not 0, 1 minus 1 is 0, and this whole thing cancels out, so plus b. So we figured out that b is 1, and if b is 1, that means a has to equal to negative 1. And then we put it back into this, it's negative 1 over n plus 1 over n minus 1. And we can move this around, and it becomes 1 over n minus 1 over n. And if you can tell by looking at this, what the series becomes after, you can tell that for every where n is smaller than 1, the number before n is being subtracted by the number before n. And to make this better to visualize, I'm going to write the first couple of series. So so we plug in 1. If you plug in 1, it's not 1, because we can't start at 1, because 1 minus 1 is 0. So I'm going to plug in 2 instead. So we do 2 minus 1, that's 1 minus 1 over 2, plus plug in 3, 1 over 3 minus 1 is 2, or 1 over 3. Then plug in 4, 1 over 4 minus 1, 3 minus, and then maybe plug in 5 now. 1 over 5 minus 1 is 4, minus 1 over 5, and it keeps going. And if you can notice the pattern here, this negative number cancels out with this positive number, this negative number cancels out with this positive, this negative cancels out with this positive. And then at the end here, if you keep going, you get something like, you plug in 6 or something, you get 1 over 5, 6 minus 1 is 5, minus. Since we're plugging in n, I'm just going to leave n over here, because if not, we're just going to keep canceling and canceling. So I'm going to end the series by leaving it as n, negative 1 over n. And then you notice this cancels out, and you're left with, so the 1 at the start is never going to cancel out. So if you compress this series down together, it becomes this 1 is always going to be here. Nothing ever cancels it out. 1, and then minus this value here. Because remember, it's going to keep increasing and increasing, and you're going to keep left, and you're going to be left with 1 over n at the end. So it becomes 1 minus 1 over n. And if you remember earlier, we take the limit of that, of this, what the series telescoped into, and then we do the limit of n goes to infinity to find the s of n of 1 minus 1 over n. If you remember, since 1 over n goes to infinity, the denominator gets really large. This goes to 0, and you're just left with 1. So overall, the series does converge, and you can see it converges to 1, which becomes the s of n. So it's a lot of work that you could be specifically asked on a test to use use this as a telescoping series to try to find the convergence, and this is how you do it.